Okay, so let's go with the question number 14. So in the question number 14, what we can say is they have given us 2 to 3 forces, which are the tension by this and also the weight of this container. So there are some forces, but the container is used to hold fans. The container hangs by a chain. Okay, this is a supporting bar. Okay, the bracket has a horizontal bar with a hook at the end. Okay, and there's a supporting bar beneath the horizontal bar as well. So this is with supporting this thing. State why the container is in equilibrium. So this is the important part. The container is in equilibrium. So if we draw, what we have to show is it's just a one marker, because the reason being, we can actually say the weight would, the chains attaching point. So if we take the free body diagram, so there's a tension here and there's a one more tension here. So what we can say is if we consider this attaching point, so that the weight do not cause an attaching point, a moment around the attaching point, we have to make sure the weight is acting in lining with the attaching point. So that's why the center of gravity is right vertically below. So here we can just write the reason, since it's just a one marker. That's the reason why it has to, because the moment has to be 0. There is no resultant moment at the, we can, if we want to like exactly say the point as well, we can say the strings attaching point. So what is important to this question to grab mark is that seeing that there is no resultant moment. So other than that, this is okay. Now they have given us a little bit like a more information. Let's see, the weight of the container is given. Okay, the weight of the container, which is 34 Newton. The mass of the bracket is negligible. Determine the force F. So we want to find this force. Okay, so what I would do is, we can get the moments actually. So either way we can do anywhere we want. So since the most of the information is around P, so I'll pick the point P. I'll consider to get the moments around point P, because then I can ignore what is the force acting by this bracket, because it's passing through the point P. That's the reason that I'm taking the point P. Okay, so we know to get that, let's see the forces. The forces would be, so now let's get the moments around the point P. So what we know is we always get the perpendicular distance. So for the, if I extend the line of weight, so the perpendicular distance between the P to the weight, this much would be 0.28 meters, and this is, sorry, this just jumped. This one would be from point P to F. This distance is a not non-distance, but we know we can of course get the tan value. So if we know this is as H, so we can write tan 55 will be the 0.16 divided by H. So H will be 0.16 divided by tan 55. So with the trigonometry we can get that value, which will be 0.112 meters. Okay, this is one important thing to get the moment. So okay, let's get the weight acting on this one, which is clockwise moment, and this one is the force F will acting as anti-clockwise moment. So we know We can write it clockwise moment. So we are getting around P, around point P, and even the question says to get the point P. So at equilibrium, we can say at equilibrium, clockwise moment equals anticlockwise moment. So once we have it, the clockwise moment we have 34, which is weight times 0.28 meters will be equals to force times 0.16 divided by tan 55. So I'll not get the simplified version, I'll keep the answer as it is. So we know this value we pre-calculated, which is 0.112 meters. So F would be 34 times 0.28 divided by 0.112 newtons. So we got F is gonna be 85 Newton. So this is how we do the question number 14b. So yeah, that's wind up the question. So we can write our final answer here, which will give us all 5 marks. Thank you.